All right, we're in business. Thank you for your patience. I hate that it feels so embarrassing to be up here. I'm a computer science person, and I'm up here trying to get my computer to work, and it's just not happening. Is this what irony is? Yeah, I think so. Let's get started. So welcome back to Comp 2150, everyone. Hello, welcome back. Today, what I would like to spend our time doing together is take a look at bindings again. So I want to quickly look through the sample that I posted last class, the bank account sample. I want to spend a little bit more time than that talking about assignment 1. And what I want to do with assignment 1 is kind of just go a little bit through the document. I don't want to spend a lot of time going through the document, but I want to spend more time going through how you're going to be assessed on this assignment. That's what I want to really focus on, is how you're going to be assessed on the assignment. There are parts to the assignment that I'm going to pick on and say hey, this is important. You should pay attention to this part when you're going through and reading the document. But I mostly want to spend time talking about how you're going to be assessed and the kinds of things that you should be doing when you're working on your assignment. And then after that, what I'd like to do is a little bit longer of a worked example. So I want to take some of the stuff that we've been talking about extensively and begin to apply that. So take this idea of encapsulation and polymorphism and OOP and just tie that all together in one bigger example to give you an idea of what we're doing with this stuff. So let's quickly take a look at this idea of binding again, just to really drive the idea home. We've got two kinds of binding. There's two places that binding is happening in the code that we are writing. The first place that binding is happening in the code that we're writing is variable binding, where we're taking statements like this one here. We're assigning a value to a variable. Our technical term here is that we're binding this value to the variable that has this name. So we're binding the value 42 to the variable that's named meaning. The other place that binding can happen is type binding. And this is where we're doing something else to a name. So we're still talking about variables. We're still talking about names. But here we're now binding a type to a name. So in this statement right here, we're binding the type int to the variable name meaning. So variable binding, giving a value to a variable, binding a value to a variable. Type binding, giving a type to a variable's name. There are two kinds of binding then. There's static binding and dynamic binding. Dynamic binding is binding that happens at runtime. So when we are running code, in Java, we have that two-step process. We compile code and then we run it. We don't always see that because we click on that run button and it just does both for us. But it's the same as what we were doing with C. With C, I keep bringing C up. I'm sorry. I keep bringing C up, but with C, you were compiling. You did clang or GCC, whichever you were asked to use, and then you did run the program. Those were two separate steps. You're doing both of those with Java. Dynamic binding is binding that's happening at runtime. So in these two examples, this line of code giving this value to a variable is something that may only happen at runtime. The variable that's named meaning may not have the value 42 until that line of code, that statement, all of the assembly language instructions for that have finished executing. So that binding happens at runtime. That's dynamic binding. Static binding is binding that happens at compile time. So when we click the compile button, this variable that's named meaning here is being bound to the type integer. And what that's letting our compiler do is say, you can't assign a string to that. You get these compile time errors that say, you tried to assign a string to this integer. That's not going to work. Rejected. I'm not even going to bother trying to compile the code that you're trying to write. So static binding is binding that's happening when we compile the code. Java is a language that's statically typed. We give types to our variables when we are declaring them. And it has dynamic class binding. So dynamic variable and dynamic class binding. We only know what kind of class an object has at runtime. We can statically assign a type to a variable, but the actual class that an object has at runtime is only something we know at runtime. So here is that bank example that I gave you last class, but I changed it a little bit and I wrote some comments in it. This is what I posted on the course webpage. So if you downloaded my sample, this is approximately what you're going to see if you were taking a look at that outside of class. On line 5, we have static type binding. We are statically binding the type bank account to this variable mine. When I compile this code, when I run javac, the variable that's named mine has the type bank account. That is happening when we try to compile the code. On line 9, we're dynamically assigning a value to this variable's name. So we're doing dynamic binding here, but we're also doing dynamic class binding. The object that's created by calling new savings account, that constructor is a method. It's a method, and it only happens at runtime. It's only called at runtime. We're asking the JDK, the JVM, to give us an instance of this object that only happens at runtime. So this is dynamic binding. I'm going to do my best. I was using words like final, keywords like final. I was putting those things into the same statement. I'm going to do my best to avoid using keywords like final. And if I do use keywords like final, I'm going to do a better job of explaining what those words mean. For the record, the keyword final means it's the same thing as const in C. This value will not change after it's been assigned. I can assign it once, I can bind a value to it once, and then that's it. I'm never going to change the actual value that this thing has. Okay. So let's have a little quiz here. These are individual quizzes, of course, but you know, feel free to talk to the person that's beside you if you want to talk about the questions that we're asking. I know how much of a race to hit the button is. I know how much of a race it is, but feel free to talk to your partner or your person you're sitting beside after you've hit that button. Little Bobby tables. Okay, I'm going to hit the start button. The pin should stay up there for the rest of the quiz. You're good, excellent. This is static type binding. This is a line of code that will be used at compile time to say, hey, there's a variable. This variable has a type, and that type is animal. Okay. This one is a multi-select. Pick multiple things, please. Okay, good, good. Okay, so good for the most part here. This line has two things going on. On the left side of the assignment operator, so animal pet, this is static type binding. So this is still static type binding. We're also assigning a value. So we're doing binding where we're assigning a value to that variable's name. And the type that we're actually assigning here is this subclass of animal. I guess I apologize for not including that directly, but I hope it was implied that a cat is a subclass of an animal. This is dynamic class binding because this line of code, or this half of that line of code, is only going to be executed at runtime. Constructors are only called when we run the program. Declaring variables is something that's being used as part of compiling the code. Constructors are only being called when we run the program. Okay. Good, great, excellent. Dynamic class binding is the only thing that's happening on this line. There's no type that's being declared here as part of this variable's name. The constraint here is that we're using Java. We're using Java for this. I will admit that, I will say that, there's a caveat to this. If this were a line of Python, then we could say that this is dynamic type binding as well, but this isn't Python, this is Java. In Python, when we declare variables, we're also doing initialization, we're also doing value binding. So we are doing just giving a name to a value, and the type is going to be defined at runtime. Lines of code in Python are only executed kind of sequentially. All right. Okay, so the next couple of questions are going to be about polymorphism and calling methods on a hierarchy. Was that somebody's ringtone or the song from Kahoot playing? Let's pop this up again. It really does sound like the Kahoot song. I wasn't trying to be mean. Okay. So which method is going to be invoked here? We've got three classes that are related to each other hierarchically. We've got dog and cat, and we've got a supertype of animal, a superclass of animal. We've got animal pet is equal to new cat. So we're static type binding the variable called pet. We're giving it a type of animal, but we're assigning a type of cat to it. So because we're assigning this type of cat to it at runtime, when this part of our code is executed, when that constructor is called, the value that pet has is of type cat. That's the kind of class that it has at runtime. So when the next line of code executes here, pet.speak, we're going to start looking at that hierarchy at the lowest part of it that the class has when that line of code is being run. So when pet.speak is being run here, the message is speak The receiver is pet. The type that the receiver has is cat. So we're calling the method cat.speak here. The one person that said this, to the one person that said this, you're right, I'm sorry. There's a missing semicolon. There is an error in this code. All right. Oh no, oh no. This is the last one. I'm going to read that line of code out. It says number n is equal to new integer number, and then n.add new integer number. If I do this again, I'm going to make the font bigger. These are my Photoshop skills. I'm sorry. I'm really sorry. These are my terrible Photoshop skills. So we've got this type hierarchy here. It starts at number. This is our superclass, the supermost class, the really superclass. The superclass number here has a method called add. The superclass number has two subclasses, whole number and floating point number. They both have an add method. Whole number has two more subclasses, integer number and long number, but they don't define their own add method. The first line of code here, number n is equal to new integer number. That's giving us dynamic class binding, where we're binding this new integer number to the variable n at runtime. And when we call n.add, we are going to start in integer number. We're going to look there, and we're going to say there's no method here with that name. So the message that's being passed to this object is add, but there's no corresponding method in the class that this actually has at runtime. When that happens, this dynamic dispatch idea, we have to move up our hierarchy by one level and then do the same thing, ask the same question. Does this class have that method? Whole number does have that method. It has an add. It accepts a type of number, so some subclass of number, which is what integer number is. And so that's the message. That's the method that the message is mapped to. Everybody's saying, shut up. Let's see what the podium is. These are adorable little things. Hey, congratulations, Manu. All right, okay. I'm going to close this. Pop over here. And we'll move on to our next topic. I'm going to go to Learn here. And so I posted, sorry it took a little bit of time for me to get to it, but I posted the link to the presentation that the Dev Club, Wix, and CSSA gave. So you can find it there if you wanted to get their contact information and you weren't able to get it when they were here on Tuesday. Our assignments are all going to be posted on Learn under content and under the assignment section here. I'm going to open up assignment 1 description. I'm going to pop this into a new window. And I'm going to hide the sidebar so that we can sort of see it a little bit better. So broad strokes. really broad strokes, this assignment is going to have you build a system that kind of works like an activity tracker. This assignment, I'm going to be really honest, I use some software called Strava to track my bike rides. This assignment is just me like pining for summer. I really want to go bike riding, not in the snow, because it's terrible to go bike riding in the snow. It's really awful. Yeah, anyway, the assignment, I am lamenting about the weather and not actually talking what I'm supposed to be talking about. This assignment is going to have you build a system where you will take a file as input. The file is going to contain a bunch of lines that are describing activities that you've done. You will be tracking those activities in your system, and then you will be querying those activities. So you're going to be asking questions about the activities, telling me how much time I've been active in total, showing specific kinds of activities between date ranges or in total, and asking questions about the activities that you got in your system that are like that. The learning outcomes that we're assessing you on in this assignment, they're kind of broad across a few different courses. Some of these are you're being reassessed on from earlier courses, and some of them are going to be from this course specifically. From 2150, the two learning outcomes that you're being assessed on in this assignment are building a simple hierarchy of classes. So you're going to be presented with a domain problem, and you're going to have to build a hierarchy of classes out of that domain problem. And using polymorphism appropriately for a problem that requires many related classes. So the hierarchy that you build up, you're going to be using polymorphism in some way, shape, or form to solve the problem. Or the solution that you come up with should use polymorphism in some way, shape, or form. We're also assessing you on some learning outcomes that you have previously demonstrated in Comp 1020 and Comp 2140, but they are integral to this assignment, so it makes sense for us to list them here as what you're being assessed on. So we want you to be able to build simple to moderately complex classes that include constructors, instance variables, methods, class variables, and class methods. So build a class, that's kind of what that one's saying. We want you to be able to compile and run a Java program with multiple files that are located in the same directory. We want you to be able to use instances of user-defined classes in other instances of user-defined classes and within main methods. We want you to write code that uses data from a file to instantiate objects. So you're going to be provided with a file. From that file, you're going to be creating class instances. And then one learning outcome from Comp 2140, we're going to be asking you to implement a common abstract data type. So we're going to have you implement an ADT in this assignment. Here's an example of what the program should look like when you are running it. You're not strictly obligated to use the exact same format that we have here, but it's going to make the graders' lives a lot easier if you stick to the same format that we're using, just so they can do a better job of pattern matching the output that you're providing to the output that we've got here. The way that this is going to work is that you are going to prompt for an input here. So you're going to be asking for an input. The person using your program is going to type in the name of the file that they want your program to read. Your program is going to report back, this is the file that I am reading right now, and then it's going to start doing stuff. So the lines that are in that file are going to tell your program to do things like add a cycling activity. So this is a cycling activity. There's going to be information in the file that matches what you see for output here. You're going to have to build an instance of a class that corresponds to the data that you have here. Similarly, there's a running activity. You'll have to do the same sort of thing. There's also going to be lines that will ask questions about the data that you currently have in your system. So there's two things that have been added here. And then there's a query asking, tell me a report of everything that's in the system right now. And it will summarize, this is how much time you've been active. These are the activities that you did that are currently in the system. You can ask questions like, I would like to have all cycling activities printed out, and it will print only the cycling activities that you have in the system right now. And then you can also do a query between 2 points in time. So I want to know how much time I was active for the month of July, for example, and it will just print out those activities that match that criteria. And then eventually your program should exit. So you should finish up and terminate everything. I gotta be honest, I don't know what you see in 1020 for reading files. Do you use Scanner? Some of you? Do all of you use Scanner? Thumbs up if you use Scanner. Everybody has used Scanner. Great, excellent. So you've used Scanner before. That's good. I don't really want you to go through and like use buffered readers and stuff like that. Just use Scanner. Just use Scanner. In fact, there are some lines of code that you can use to get an input stream for a file so that you don't have to like go through all that mess of figuring out how to do input with files and Scanner. You could just copy this line of code and use it. Good, excellent. The structure of the code that you're going to be creating. So we're going to list out here the kinds of things that you need to represent in this system, the kinds of information that you're going to need to track, and the kinds of things that you're going to need to calculate based on the inputs that are being provided to you. There's like a subtle hint here where these words are bolded that kind of imply you should make a class out of this thing. There's a subtle hint. You've got activities in your system. These activities are going to be the things that your system is going to be tracking. The specific kinds of activities that you're going to be tracking are bike rides or cycling. So those are synonyms for each other. For bike rides, you're going to be keeping track of things like the distance, the total time that you spent doing it, and then you're going to calculate things like the average speed that you have. Runs and walks are two separate kinds of activities. So running and walking, these are two different kinds of activities. They're both going to be tracking things like how long you did it for, how far you went, and what your pace was. So how long it took you to go a kilometer on average. And then swims. So the same sort of idea. Swims are a little bit different because you're going to be tracking how many laps you did in the pool as opposed to how far you went and how long one lap is. The queries that you're going to need to support are going to be things like querying everything that's in the system right now. So these are just printing out all of the activities that you have in the system. The amount of time and the activities that you've done of specific types, the amount of time that you spent between two dates, and the activities that are of a specific type. The caveat here is that, the one caveat here is that you shouldn't allow duplicate entries in your inputs. You shouldn't allow duplicate entries in your inputs. If I, for example, made a mistake in the file that contains all of my activities, and I put the same thing twice, the exact same line twice, then only one copy of that should be put into the collection that I have. That's an abstract data type. That's an abstract data type. You can feel free to just shout it out. It's fine. It's totally fine. It's a set. It's a set. It's a set. It's a set. So we want you to implement this as a set. Two activities are duplicates. They're identical if they have the same properties. This is importantly different from being the same object. Two activities are the same thing if they have the exact same properties. That's importantly different from being the same object. Here's a complete listing now of the format of the commands that you're going to be getting as input. All commands are going to have some common properties. They're going to have a name. The name is anything, it's any string, but it doesn't contain any white spaces. So you don't have to support like keeping track of white space between things. It's just going to be one single word. But anything is okay. There's going to be a location. This is also just a one-word thing. It's just a string. It can contain anything. But normally what we would be writing in here is like Winnipeg or something. There's going to be a date. The date is going to be of a specific format. So it's going to have year, month, day in that exact format. And you should be using Java's local date class to help you with this. So here's a link directly to the, great, thank you. I hate clicking accept all on things. I guess it's nice that they have a decline all button. Here's the local date class. This is a class from the JDK that you are permitted and encouraged to use. You'd be making your life harder if you don't use this class. This class has a lot of things that you can do, like comparisons between dates, arithmetic on dates, and parsing dates. Really importantly, there's a method in here to parse dates. So if I keep going down, there's this method parse. This method will accept a string that's formatted in that specific format, and it will give you back an instance of this local date class. And you should use that in your classes. The other thing that's common between all activities that they're going to have a duration. Duration is going to be in kind of a weird format. Duration is just how long you are doing something. But we're asking you to use the duration class. So duration is another class that you have access to in Java. It has this nice parse method. And what's nice about this is that you can do things like arithmetic, and you can do things like going between hours and minutes without having to do the complex logic of you like parsing out 3:15 and then trying to decide how to add those things together in minutes and hours and stuff. You can just use this duration class, and it will do all of that for you, and you can get hours and minutes back out. One thing that I would suggest that you use in this class when you're doing, you're trying to go from a duration to the format that we're suggesting. So I'm going to scroll back up here really quickly. When you're doing stuff like this, 2 hours and 45 minutes, there's a 2-hour method on duration, and then there's also a 2 minutes part method. And the part method will give you like the modular arithmetic of whatever's left over after you've converted it to hours, or the next greatest unit for durations. This one, I'm going to really say you kind of have to use this class because of the way that we're formatting the input for you. It's very specifically formatted to meet what this parse method is parsing out. Here are some examples of the kinds of inputs that you can expect to see in the files that you're parsing. So here is a cycling activity. The name of this is perimeter circuit. The location is Winnipeg. The date was July 23rd, 2022. This is the duration part of it. So this is, don't quote me on this. You can quote me on this because I'm going to look it up. This is something called the ISO 8601 standard to describe durations and time. The P stands for period. The T stands for time, 2 hours, 45 minutes. That's what that's saying. This is just a nice way to represent durations. And then this is for 80 kilometers, and there's an elevation gain of about 50 meters. For the record, that elevation gain is entirely going over the bridges at the intersections on the perimeter highway. Walking is going to be approximately the same. So the name of the type of activity, the name itself, the location, the date, the duration, the distance, and the elevation gain. Running is the same. Swimming is the one that's going to be a little bit different because you're not tracking distance, you're tracking laps and how long each lap is. So this one is saying that we've got a swimming activity. It's the open swim at Penn Am Pool. It took place on the 10th of January, 2023 for 30 minutes. We did 10 laps, and each lap was 50 meters in total. The queries that you're running here are going to look like this. So the line will contain the word query. It will contain the word activity next, and then it will contain the type of activity that you're going to be querying. This is going to be exactly the same as the first word that's in the activity listings themselves. Query total time is going to print out. This is all of the activities that are in the system right now, and then query between is going to be dates. There's also an optional thing to support here, which is the word today, which is just going to use the date that it is right now when this program is running. So whatever day it happens to be when the program is running. And the last command that you need to support here is quit, and that just turns off your program. When you're submitting, we're asking you to submit everything to Learn, so we're not asking you to use hand in for this. Yeah, hooray, okay. Don't get me wrong, I seriously thought about it, and I tried to convince Olivier to use hand in, but he didn't want to do it. So you should actually be thankful to Olivier, not me. You're going to use Learn. We want you to take everything that you've got for your submission for your program and just zip it up and submit the zip file. It would be great if you would include a plain text README file that describes how to compile and run your program. There's not really a lot of imagination in this because it's mostly just going to be javac star.java and then Java, whatever your main class's name is. This is a link to some stuff that I wrote that kind of goes through how to write Markdown. But for the most part, what I'm looking for when I think about you writing a Markdown file is just something like this. Underlines for the things that you're writing. So using using equal signs for a top level heading and then single dashes for a second level heading. All right, so for assessment. Before I move on to assessment, this is so much, this is a lot, I'm really sorry. Are there any questions that anybody has about the assignment itself in terms of what it's supposed to do? Yeah.
I see that we're supposed to put the activities and put them in a linked list to search through, but how is that hierarchical?
So there's two parts to that. The activities themselves are hierarchical. So all of these things are activities. All of those things are activities. Your system is going to have a linked list that contains activities. That in itself is hierarchical in the same way that our bank accounts are hierarchical. We have some super type, and then there's subclasses that come off of that. That's the hierarchical part of that. So one thing that you should be looking for when you're reading this and when you're thinking about how to design your class hierarchy is, what are the similarities between these things? What's common among all of them? And then what's different among them? And how would you organize your activity structure based on that? Yeah.
So these are all activities, like bike rides, runs, walks.
Yeah.
But are we only going to be having like bike rides, runs, walks, and swims? Or could they throw, oh, I went bowling?
That would be terribly cruel of us to do something like that. No, it's limited to just these activities.
Okay.
If you want to add support for your own kinds of activities, yeah, please go ahead. But we're only going to make files that contain the activities that are listed here. Yeah. Yeah, so I'm going to get to that in a second. Yes, I know, and we all know that the JDK has a set class, but you should not use the set class. You should build your own linked data structure for this to implement it. Yeah.
Can we expect that the input file for testing our solution is like error-free from spelling mistakes, things like that?
You can expect that the input file will be well-formed. So it's not going to have like misspelled cycling or something. We're not going to expect you to support handling those kinds of issues.
But maybe duplicates.
Yes, so there's definitely going to be duplicates. We're going to be testing you with files that are duplicates because that was explicitly stated as part of the assignment's problem, yeah. Okay, so I'm going to scroll down here to assessment. You're going to be assessed on on many different things for this assignment and all assignments in this course. The first one is going to be pretty consistently applied through all of the assignments that you're going to be submitting for the course, and that is the programming standards. There is a document that's under the course resources section. I believe that's what the section is called. General information, I'm sorry. So there's a link here to programming standards under this general information part of the course content. Your submission is going to be assessed out of levels here. So kind of meeting the programming standards that are stated in that document. The output that you are producing as part of your program. So some of the things that you're outputting are going to be calculated, like the pace and the average speed, for example. These are calculated. And then just all of the outputs that you're producing as part of this for the queries. You're going to be assessed on that out of 5 points in total. And then the learning outcomes themselves, this is how we're going to be assessing you on those learning outcomes themselves. So learning outcome 1 is build that hierarchy of classes. And we've got these levels here and the number of points that are being allocated to that learning outcome itself. So this one has a total of 4 points. And to meet the level 3, what we're looking for is an appropriate hierarchy of classes for the stated problem. There are many ways to solve this problem. And what we're looking for is that you're applying the concepts that we're talking about in this class appropriately to the problem that we have. If you just jam everything into one single class, that's an inappropriate way to solve the problem. You may be able to do it, but that is not an appropriate way to solve this problem. Learning outcome 2 is use polymorphism. So polymorphism here is making sure that you've got classes that are implementing the same method in a hierarchy and that the correct method is being used in those classes, regardless of the static type that's been assigned to a variable. Learning outcome 3 is compiling learning outcome 3 is about, this is the 1020 outcome about using user-defined classes. So this is making sure that you're using user-defined classes in several places. Learning outcome 4 is it's effectively does your code compile. So you submit something, does your code compile? Learning outcome 5 is that one is user-defined classes across multiple places. The one that I'm really interested in here is learning outcome 7. So this one is about the implement commonly used abstract data types. This one is very explicitly saying that to reach the top level, you have to use your own linked data structure. You have to implement your own linked data structure. So please don't use the set or the built-in types. This is what we would call a level 0 assessment of that specific learning outcome. If you use arrays, yeah, you can solve this problem with arrays. If you make a 1,000,000 length array, you're probably never going to run out of memory for this, but you shouldn't use arrays. You should use a linked data structure to get full points for this. There's one more thing I wanted to say, and it's written in here, but I forget where it's written in the assignment. It is written in here, I'm sorry, I just don't want to spend a bunch of time like scrolling up and down trying to find the exact text of it. We have provided you with one sample input, and the sample input is what matches the output that you see in this document. So there's a file that's sitting alongside this PDF that has the set of commands that were used to generate the output that you see in this document. You should make your own input files. You should also make your own input files, and you should be testing things that you would want to test to make sure that your code works as it's supposed to work under various conditions. One of the things that Comp 2160 is supposed to be covering is doing things like testing edge cases. I'm going to give you some examples of edge cases. I'm going to give you some examples of edge cases right now of the kinds of files that you might consider producing to test your own programs. The kinds of edge cases that you might want to consider testing are querying no activities. What's the total time for no activities? That's a valid input. That's a completely valid input. That is an empty list kind of edge case. There's nothing in this list, but I should still be able to do things with it. This is supposed to be a set. What happens if you have the same line multiple times? The input that we're providing to you does not have that example. What's it supposed to do if there are the same lines multiple times? What if there are the same lines multiple times on very far apart lines in the input that you're providing? So one cycling activity, a bunch of walking, and then the same cycling activity. Does it still work the way that it's supposed to work? What happens if your input only contains all of the same line? They're all the same line. You have 10 of the exact same line, and then you query it. Does it do what you're expecting it to do? What happens if you are querying between dates where the dates are exactly the same as the dates that you've got as activities? So the query format for between is, now you're going to watch me scroll down here, is between start date and end date. I'll say for sure the dates are not going to be reversed. You're not going to have this weird situation where the dates are not, in the correct order. It will always be correct that start date comes before end date. That will be true. But start date might be the same as end date. And what happens if the only activity that you have is the same as the start date, or the only activity that you have is the same as the end date? Does the word today work? Does it work the way that you're expecting it to? The inputs that we're providing to you don't include the word today, but if you have an activity that is on today's date as an input, then querying for today should work. It should provide that as an output. Those are some good examples of the kinds of things that you might want to produce as input files for yourself for testing to make sure that your code works the way that you expect it to work. All right, and with that, I'm going to stop and I'm going to count to like 20 Mississippi in my head, and I'll just wait and see if anybody has any questions. Yeah.
So for the assignment, the file name is like inputted by the user into the console, and then after that, all the other input comes from that file.
That's right. So the question is the name of the file the only input? That's approximately what your question is. Yes, the only thing that's input by keyboard is the name of the file, and then everything else is you reading the file. Yeah. Yeah. You can safely assume that the file will be well formed as an input. So it's always going to have the correct number of parameters. You can also make assumptions like, this is stated in here, but I'll say it again. You can assume that the number of kilometers, for example, is a whole number. We're not going to be giving you 50.2 kilometers. You can also assume that the elevation is a whole number, the number of laps is a whole number, the distance in a lap is a whole number. You can assume those sorts of things. Yes. You can assume that when we have a walking or a running or whatever, it will always have the right number of parameters, the way that it's specified in this format. Yeah. There's somebody down here, I think, that had a question. We good? Good to go? I mean, nobody likes it when somebody says, hey, here's a massive assignment, go to it. But I'm going to politely remind you that questions that you have about the assignment, so about issues that you have with the assignment or clarifications that you have about the assignment, I'm going to really kindly ask that you put them on the course forum. You can post anonymously there, so if you don't want to like out yourself as somebody that's asking the question, you can ask the question there. For complete transparency, anonymous on Learn forums is that I can see who you are if I click a button. So when I see posts on the forum, they show up as anonymous. I never click on that. That's my word. Yeah, I know it's kind of like just me promising something and you have to trust me, but I don't click on that link. So I don't really like to see who's making the posts. But just for full transparency, you can do that. Other students can't, of course, see who has made an anonymous post. If you have a question about your own personal circumstances, of course you should email me. You should absolutely email me. If you don't want to post in the forum, you should, of course, just come to my office and talk to me. I'm more than happy to come and talk. I'm more than happy to have you come and talk to me. I'm not going to come to your house and talk to you. All right. Okay. So that's, wow, that's a lot. Okay. Everybody stand up for a second. Please stand up. Please stand up. Stand up, stand up. Okay, stretch yourself out, yes. I gotta be honest, I'm overjoyed that I have this power over a classroom of people. Okay, all right, yeah, sit down now. Yeah, okay, sit down. Why did I make you do that? Do you want me to make you do jumping jacks too? Like, yeah, you got to start tracking activities. That's right. Yeah. So yeah, stand up 30 seconds. Yeah. Okay. So here is a short snippet of this example that we've been spending time looking at. Here's a short snippet of this example that we've been spending time looking at. After class last time, somebody came and asked me a question, which is a totally legitimate question. Why are we declaring this bank account and then assigning a savings account to it? And then later checking to see if it's of type savings account and then casting it to savings account. Why not just make it a savings account in the first place? And I think that's a totally valid question. I think that's a totally valid question. The worked example that I want to go through here is, let's take this contrived example and make a bigger contrived example, but one that's going to satisfy these requirements of, I want to be able to actually have meaning behind this. Why am I bothering to do this whole, use the superclass as the static type and then cast it down to some other type later? I want to justify the need for something like this. So the worked example that I want to do is to take this bank account idea and build on that. And instead of having just one bank account, I'd like us to build a bank. Banks, I think we can all agree, are buildings that have collections of accounts in them. They've got a whole collection of accounts. Every bank has a bunch of accounts in it. Banks are notorious for having like a million different kinds of accounts. They call them products, apparently. And if we go to bank accounts here and we browse all accounts, there are 10 different kinds of accounts. And I guarantee that that's not all of the kinds of accounts that this bank has, but this is at least all they're telling us, you know, lowly plebs that are using bank accounts for the hundreds of dollars that we have. What I'd like to do is go through the process of designing this. I want to take some time to design what it is that we're planning to build. And then I'd like to take the time to go through a couple of stages of building it to satisfy different requirements that I have that I want to use to build this thing up. The solution that we're ultimately going to see here is going to use abstract classes and methods. So this is, again, a throwback to Comp 1020. This is one of the learning outcomes from Comp 1020 is to use abstract classes and methods. And we're going to be using polymorphism and dynamic dispatch in this solution that we're building up for this. I'm ultimately going to be building off of the bank account stuff that I have published on the course webpage. So if you want to code along, you would want to have that sample from the last class that I published up on the course webpage. So first things first, here's the design that we had before for our bank accounts. These are the two kinds of bank accounts that we've got, a savings account and a checking account. And they come from this superclass bank account. What I want to do is I want to make another class. I want to add another class to this system. And the other class that I want to add to this system is going to be my bank. It's going to be a collection of the kinds of accounts that we have in this system. So I'm going to create a new class in this called bank. Whoops. Here's my new bank type. My bank is going to have accounts in it. To support this, I'm going to want to create a new linked data structure. So yes, I could just use Java's array list. I could use Java's linked list. I could use Java's set or whatever, but I'm not going to do that. I'm going to build my own linked data structure. My linked data structure is going to be imaginatively called a linked list, and I'm going to give it a type of node. So the linked list that I'm going to use is just going to be a single class that's just because type node. I want my accounts in my bank class to be the start of this list. So I'm going to say note for bank. Accounts is the head of a list. There's one really obvious way to just do what we want with what we've got right now. There's one extremely obvious way to do this. One is we've got two different kinds of accounts. Let's have two lists. Savings accounts and checking accounts. That'd be fine. It would work. That would be fine. It would work, but it's not ideal. It's not ideal. It's not ideal because we really want to be able to have any kind of banking account in this same collection. What I really, really want is to be able to put all of the types of bank account into a single list of accounts. I don't want to have to know or care what kind of account they are in this collection that I'm building up. Part of the reason for that is a design reason. I want to be able to add accounts to my system. I want to be able to add new kinds of accounts to my system without changing how the bank class is structured. So what I'm going to do to start is I'm going to say that we're going to have a node that's called accounts. This is going to be the head of our list. The node class is going to have the data, the thing that we actually want to have in this linked list. It's going to have a link. The next node in the list, And then we're going to have a couple of methods to be able to work with this. So I'm going to make a method here called print, and I'm going to make a method here called getNext. I'm also going to add a method to bank, and my method for bank is going to be called printAccounts. I think this is enough design for now. So let's start coding it. Let's start writing this up. I'm going to put this to one side. I'm going to make a new file here. So bank.java. This doesn't extend anything. This is just a class that stands alone all by itself. I'm going to make a new class here called node. This doesn't extend anything. This just kind of sits along by itself. It's going to be used in other classes, but we're not using this in a hierarchical way yet. My node class has a bank account. I'm going to mark these as private. These are instance variables that we don't need to expose to the thing that's using the class that we're making. Got a next public node. I'm going to make a constructor. My constructor is going to take as input both the account and the next node. I'm going to add an accessor. I'm going to return my next node. We good with this so far? Straightforward node. There's not a lot going on here. Not much code. It's just there. Yeah. Yeah. They use a database, a proper database, but they also use mainframes and they use COBOL, languages that were invented in the 60s. If you want to make a lot of money, you should learn COBOL. I'm not kidding. They will pay people a lot of money who know COBOL very well, because the people who know COBOL are retiring and dying, to be blunt. So if you want to make a ton of money, but be really, really bored and work at a bank, you should learn COBOL. I don't know why you'd learn COBOL. Why would you do that to yourself? Okay, so we got a node, we've got a list, we've got the start of a list. I'm going to switch back to my bank here. My bank needs a type node, private node, accounts. And I'm going to put that comment, that same kind of comment here. This is the head of a list. I'm going to make a constructor for my bank. I'm going to say this.accounts is equal to null. So we have no accounts in the system to start. I'm going to add a method here that's going to add an account. So I'm going to say void add account. I'm going to take another method here that's going to accept a new bank account for me to add to this system. Adding an account is going to be making a new list, making a new node for my list. So to make a new account here, I'm going to say this.accounts is equal to new node, the account that was passed as input to me. So to this method, I've been passed this account. And the next that I want to have here is, I better change that to be something else. Accounts list. I'm going to call this accounts list. So let me expand this a little bit. Here we are inserting a new list, a new node to the list. That's what we're doing here, just adding a new node to our list. I'm going to add a print method here. And this print method is going to rely on the nodes printing themselves. So I'm going to say if accounts list does not equal to null, if I've actually got an account in here, print the accounts list. Let's add that corresponding method to my node. Spell this correctly, spell this correctly, spell this correctly. And I'm going to say system.out.println. And I'm going to say account.toString. In the last class, we wrote these toString methods that we can use in those classes. So I'm just going to reuse those toString methods here. I want my list to print itself. So what I'm going to say is, if next does not equal null, next.print. Okay? I'm going to go out and say this. I'm just going to go out on a limb and say this. That looks a little weird. That looks a little weird. It does look a little weird. If you're not comfortable with this, one thing I'm going to suggest that you try out is like drawing out our linked list and seeing which method is being invoked on which node as we're going through the process of calling this method. I'm going to do in my main class here, in my bank class, I'm going to write a main method. And what I want to be able to do with my bank is start adding some accounts and printing things out. So I want to actually be able to use the list structure that I've created here. So I'm going to say bank is equal to new bank. What kind of typing is this? Please just shout it out. Static type. Everybody shout it out. Static type. Thank you. Static type. What kind of binding is this? Great. Excellent. Thank you. I really appreciate it when you play along. Good. We've got a bank. I would like to be able to add some accounts to this. I'm going to say bank.add. And what I'm actually going to do here is go back to my main class. And I'm just going to copy and paste these lines rather than mistyping it 1,000 times. The account that I want to add here is a new savings account. I'm going to make this bigger. I'm going to put this below so that maybe it's a little bit easier to see all at the same time. And I'm going to add a new checking account. The initial balance is, let's say we got $400 and 20 checks. I'm going to print out my bank here. And what I want to have happen, what I'm desperately hoping happens here, is that we have a list of accounts that are all of type bank account. But they're going to print out the appropriate toString for each of the kinds of accounts that we have passed to this. I'm going to save my node. I'm going to save my bank. And then desperately, as our class is ending, I'm going to hit the run button. Holy shit, it worked. Good. Yes. Excellent. Okay. This isn't the end of this, though. We're going to keep working on this on Tuesday, and we're going to make some changes to this. There are limitations to this list structure that we've got right now. The primary limitation to the list structure that we've got right now is that this only works for bank accounts. I would like to have a list structure that will let me use any kind of type in Java. I don't want to be limited to a list with bank accounts, because then we're back in that same problem with C, where we have to make new lists for every kind of thing that we want to store. Thank you all for coming out, and I will see you on Tuesday. Bye, everybody.